Okay, class, so we're going to start off on the next section. But before we do that, I want to go over some basic information that you're going to need to know for the next section. And we're going to start with some very basic facts, but they're very important facts because they can help you a lot in the next section. So let's say here, for example, that I have a segment, and I have the segment broken up into two parts. Part of it is 4, and the other part is 12. And I asked you, what's the total length of that segment? I would hope that the answer you give me is 16, because the 4 units plus the 12 units will give you a total length of 16 units. Well, let's take the question a little further now. Let's say I give you a segment that has part of it is 4 and part of it is x. And I ask you, what is the total length of that segment? Well, then I would hope you would still recognize that you're going to do the same thing. You're going to add this component of the segment plus this component, and you're going to get 4 plus x as your answer. The length of this segment, whatever it is going to be 4 plus the x, not 4x. Because 4x indicates that you would be multiplying 4 times x. And obviously, that's not what we're doing here. We're not multiplying. We're just adding these two parts, these two segments together. So the length of my entire segment would be 4 plus x. Now I know that seems pretty trivial right now, but when we get to the next section, you'll see why it's so important. Here, I tell you that a part of the segment is 4, and I tell you that the entire thing has a length of 16 units. And I'm asking for you to tell me now, well, how long is this part here? Well, you know the whole thing is 16. From here to here, you've used up 4. So you're going to end up subtracting. 16 minus 4 is going to give you 12. And I think you agree that 4 plus 12 is going to give you the 16 that you need for the entire segment. But there's another way that you could name this. Let's say that you didn't want to put it down as a number. Let's say you wanted to put it down as an algebraic equation, right? Well then, this could be said to be 16 minus 4 would be another way to put this. Because how did I get this part of the answer here? Well, I took the 16 and I subtracted 4 from it to get the missing part, right? So another way to say this is 16 minus 4. Okay, why is that important? Well, let's say, for example, that you have another segment. I'm going to break that up into two parts there. And let's say that the entire thing, again, is 16 units. And I tell you that this is x. So this is what you have. Here's the scenario that you have. They tell you that the whole thing is 16. They tell you that this is x. Well then, what would you put here as your component? What would it be here? You don't know what number it is, but you know that whatever it would be, just like we did here, 16 minus 4 to get 12, you do the same thing here. So this would also be what? 16 minus x. So this part would be x, and this part would be whatever it is, 16 minus x would give me this part here. And of course, if you notice, if I add these two together, x plus 16 minus x, the positive x and the negative x cancel out, and I'm left with 16. But I want you to see here how this is 16 minus x. Why is that important? Let's take a look why. In front of you, in your notes, you have the rules for the new section. And you're probably reading the rules, and you're not really sure what they mean. And that's okay. So let me tell you what they mean in English. Here I have a circle, and I have two tangent lines coming from one external point. You know already from experience that when I have two tangent lines coming from an external point, that they are both going to be congruent. Hence I have the congruency dashes here. But in this scenario now, I have an exterior point, but these are not two tangent lines. These are in fact two secant lines because they're going through the circle. And there isn't any rule that tells us that secant lines are congruent. The only lines that we know that are congruent are tangent lines. So the question becomes, how do I find the missing length here of this chord? Or better yet, I also would probably be the, if I know this part, I would know the whole length of this segment, of segment AE here. So how do I find it? Well, the rules tell you how to find it, but I'm going to explain it in a very, very simple way. When you want to find out the missing portion of your segment, what you want to do is, let's start on this side here. Let's start with this segment here because we have numbers that we can work with. What you want to do is, you want to take the outside portion of your segment, which is 4, and you want to multiply that with the length of the entire segment. So the entire segment is 4 plus 8, which is 12. So the outer portion, 4 times 12, you can set that equal to the outer portion of the other segment, which is 5, times the entire thing. And here's where that basic info that we talked about earlier comes in play. What's the length of this entire segment here? Is it 5x? No, it's 5 plus x. And basically what the rule is saying is that the product of the outside part and the entire segment is equivalent to the product of the outside part here and the entire segment. So 4 times the whole thing is equal to 5 times the whole thing. And now let's do a little algebra here. So 4 times 12 is 48. I can't add these two, but I can distribute. 5 times 5 is 25, plus 5 times x is 5x. And now I have an algebraic equation where I'm going to subtract 25 from both sides. This is going to give me 2, 3 is equal to, that cancels out, is equal to 5x. Now I'm going to divide both sides by 5. And x is equal to, well, let's take a look here. 23 divided by 5 is 4.6. So the length of this segment right here, x, is going to be, excuse me, of this chord here, this portion of it is going to be 4.6 units. And by the way, do these two entire segments have to be congruent? No, they don't. No one said they did. We're just looking for this little portion here, and the rule says that if I multiply the little part times the whole thing, its product is going to be equivalent to the little part on the outside. Forgive me, little probably is not the right term. The part on the outside times the whole thing. Let's take a look at another example. This one looks a little complicated. But trust me, if you stick to the steps, you'll be all right. They're telling me here that this entire secant line is 16 units long. And they're telling me that the outer portion here is 4. And in this scenario, they're also telling me that this entire secant line here is 32. And this little portion right here is x. And they want me to find this little external part out here, x. Okay? So let's start working out on this side here because we have some numbers. I like starting with the numbers. Well, the outer portion is what? Is 4. And I'm going to multiply that with the entire length, which is what? Which is 16. And that's going to be equal to this outer portion here, which is x, times the entire thing here, which is 32. It seems pretty easy now because I don't have to distribute anything or more than one thing. So 4 times 16 is 64. That's equal to x times 32 is 32x. Obviously, I want to solve for x now, so I'm going to divide this side by 32. Divide this side by 32. So 64 divided by 32 is 2, and that's equal to x. So then I know that this little part right here is equal to 2 units. And I know at first it looked intimidating because you had all these lines here, but if you stick to the rule, it's pretty simple. Let's do one more example together. Here I have the outer portion is 8. This is x. This outer portion here is 10. And this part here is 16. And they want me to find x here. Well, again, I'm going to stick with the rule. The rule says the outer portion is 8. And I'm going to multiply that times the entire thing, right? Well, how long is this entire segment here? Well, it's 8 plus x. Remember? It's 8 plus x. It's not 8x. It's 8 plus x. And that's going to be equal to this outer portion here, which is 10, times the entire thing, which is 10 plus 16, which is 26. And this time, I am going to have to distribute a little bit more than once. But that's okay. Let's try it out. So I'm going to distribute the 8 there and the 8 there. 8 times 8 is 64, plus 8 times x is 8x, is equal to 10 times 26 is 260. Now I have an algebraic equation, so what I'm going to do here is I'm going to subtract 64 from both sides. These are going to cancel out. 8x is equal to 260 minus 264. Excuse me, 260 minus 64. It's going to give me 196. Now I'm going to divide both sides by 8. And x is going to be equal to 196 divided by 8 is 24.5. So this part right here is 24.5 units long. And that's how we do the length of 2 secant lines in a circle. Next, we're going to talk about